Miniature Steam Hacks, Hints and Tips. This is part 4, and it's a compilation of very useful information. I temporarily fitted a stud into the engine, and then I used the 3/16 drill through this 3/16 hole in the piece of steel to make a small mark on the engine bed plate, after which I used a tapping size drill, which is 5/32 of an inch, and I tapped this hole also 2BA. I cannot stress how you must be really careful doing jobs like this. You need to be very delicate. Firm, but delicate at the same time. If you dither, you will have problems. If these holes in the pump valve were all the way through the flange, it would be easy. I could simply stick the new flange to the old flange with some Loctite. Then all I'd have to do is scribe through from behind, but no such luck. These are blind holes, which made them quite difficult to tap with the 8BA plug tap that I used. After a little bit of thought, the quickest method seemed to be this one. I used the original fitting to centralise a piece of paper on the existing flange, and then I just used a pencil point to press the paper through the holes. I could have used a scriber, but I just had this pencil on the bench and it was close at hand. All I then had to do was remove the piece of paper from the centre threaded part that was in the valve, and then I machined the centre threaded part a little bit so that it fitted into my new flange, and refitted the paper. And if you think about it, this is very simple, very straightforward, not clever at all. All it does is holds the paper pattern exactly in the middle of the flange, which is where it was in the first place when it was screwed into the valve. All I have to do now is carefully press the piece of paper down onto the new flange. I'm using the hole in the end of my adjustable spanner to do this. Once the piece of paper is firmly pressed onto the new flange, all I have to do is use a small felt tip pen through the holes in the piece of paper to make marks on the flange. Then it's over to the drilling machine, and I initially drill the flange with a small centre drill. I'm drilling these holes as perfectly as possible. I can clearly see the mark on the flange, and with a bit of experience, I've had plenty of that, I can generally drill a hole on a mark. I don't need to make a centre pop in it first. So if you're lacking in confidence or experience and you're doing a job like this, use a centre punch and make a little centre pop, and this will hopefully keep the centre drill in the correct position. It's always a good idea to use a tool like this to remove the square edge. Any edge at 90 degrees is razor sharp. Here's a 7/32 of an inch hole drilled in a piece of brass plate. And as you can see, the burr on the underside is much greater than the one on the top, but there's still a burr on the top. By holding the tap guide firmly against the work, this keeps the tap at 90 degrees to the work, and you get a very clean thread, and more importantly, it's not at an angle. So whenever you screw anything into the hole, it's perfectly vertical. For the newcomer to model engineering, these are very useful things to have in your workshop. It's a good idea to make one for every tap size that you have. When setting the valves, always rotate the engine in one direction only. Never go backwards, because any backlash in the chain will not give you a true reading when you're looking at the valves in the valve chest. This video about valve timing is a little back to front. There is a reason for this. It's just to try and make you understand what's going on before we get down to the nitty-gritty. The first thing to do is set the eccentric. The eccentric needs to have the highest point of the eccentric set at 90 degrees to the crank pin. This is in a good enough position to be able to set the valve accurately. When setting the valve, make sure that it uncovers the ports at the top and the bottom equally. This is very important. It has to be in the middle. Don't worry if it wobbles around a little. The slide valve has to have some float. Once you have the valve in the correct position, rotate the crankshaft. Adjust the slide valve position so that the top inlet port is just cracked open very slightly as the piston gets to top dead centre, and similarly do it with the lower port. Adjust the slide valve position so that the bottom inlet port is just cracked open as the piston reaches the bottom dead centre. Adjust the valve as necessary to get this to happen. Then replace the steam chest cover and connect a compressed air supply to the engine. Don't use too much pressure, you just need the engine to run nice and slowly so you can see what's happening. Now you need to adjust the eccentric slightly to achieve the type of admission that you require for the steam engine application. This is a quick tip: when using slotted grub screws, always make sure that the slot is below the surface level, because otherwise if you put pressure on the slot with a screwdriver, one half of the slot normally breaks off, and then you end up with a broken grub screw, and it may be difficult to get it out. So make sure that the grub screw is definitely below surface level, which supports the sides of the slot. A good indicator of the status of the running in procedure is the colour of the lubricating oil that is exuding from most of the parts of the model. Here you see down this green part, nasty black oil. This is oil mixed with the metal residue from the bearing. And this is nothing to worry about on a new engine or an engine that's had some new parts fitted. But if this continues into the life of the engine, then something is wrong and needs investigating. If the oil's coming from the main bearings, it could be either that the caps are too tight, putting too much pressure on the bearing, or the bearings got scored and is re-wearing itself back into play. Here you can see some black oil around the gland nut of this beam engine. This is because the gland's been recently fitted and it's quite tight. After a while the black oil disappeared. Looking at the exhaust pipe, you will see black oil coming out of there too. This should happen for a while, particularly as the piston does a lot of work and wears itself into the bore. If your steam engine has a piston that's packed with graphited yarn, also known as soft packings, you will get some black residue like this until it all settles down. With this James Coombs model engine, after a couple of hours running, the exhaust residue became very clear. The oil that came out was the same colour as the oil that went in. But steam engines like this are better run at a scale type speed, more like you see here, nice and steady. Although sometimes it is good fun to open the regulator wide and watch the engine spin away. This has a governor, but the linkage is quite ineffective. It does not shut off the steam properly, or in this case compressed air. An engine of this type going like this, it nearly dances off the bench. Usually when I've finished rebuilding an engine, I run it at warp speed for a few seconds like this, and I don't recommend this, but it does show you that the engine's in good order. If anything was wrong, it would really show up at this speed. But don't do this for a prolonged period, because the oil will be spun off by centrifugal force and you'll end up with dry bearings very quickly. A quick word about oil additives. A few years ago I was working at an oil refinery in Glasgow, and I was speaking to a laboratory man, and I was asking him which is the best oil additive, and he said, by far, without a doubt, rapeseed oil is the best additive. And I thought, what? Rapeseed oil? But then he went into great detail about it, talking about such things as long chain molecules and binding to this, that and the other, and I thought, well, he must be right. So the next time I went up to the Model Railway Society, I was speaking to some of the men who used to work on the railways in the old days, and I was telling them this story of the scientist at the oil refinery, and they said, yeah, he's right. They said years ago we used to have something called the special stuff in the superintendent's office, and if one of the engine's bearings was running hot, as was common with the inside cylinders of steam locomotives, they used to get some of this special stuff and add it to the oil, and it was rapeseed oil. You live and learn. Thanks for watching. I hope you found it useful.